Our universe contains trillions of stars. In between and around those stars are other things like planets and nebulas. Some planets are just big round rocks. They don't have an atmosphere or magma or melted rock inside them. Other planets are made almost entirely out of gas. And then we have Earth, which has a wonderful balance of solid rock, liquid water, and a gaseous atmosphere. Have you ever wondered why Jupiter and Mercury are so different from each other, or how planets formed in the first place? I'm Science Mom.
And I'm Math Dad.
Today we're going to learn all about the 8 planets of our solar system. Hello and welcome! We asked in the chat before class started if anyone had a favorite planet besides Earth, and it has been really fun to see all the different answers and reasons.
Type yours in if you haven't yet.
And if you are watching the replay, go ahead and leave a comment. Let us know what your favorite planet is and why. I have to say, my favorite, of course, is Earth, and there really is no planet B. There is no planet in our solar system like Earth, and today we're going to learn more about our own planet by comparing it to the other planets nearby.
But I thought this was an Earth science course, Science Mom.
This is an Earth science course, but sometimes the best way to learn about a specific topic, instead of just zooming in as close as you can get, sometimes it's nice to zoom back and get the bigger picture.
You know, that is true in math all the time, that if you focus on a specific problem, it can be kind of difficult, but taking a step back and looking at a broader context can teach you way more.
It definitely can, definitely. So let's start off with the closest planet to our solar system, Mercury. We're going to take a quick tour through our solar system. This is how Mercury would look if we were in a spaceship looking at it. It would be gray, a big gray rock. But if we look at an enhanced image that was taken by a spacecraft that orbited Mercury for quite a long time, it took a lot of different photos and then overlaid them and colored the data so that you could see the difference between different types of rocks. Rocks that are tan are rocks that came from lava flows where the lava was viscous and runny. The bluish rocks are not as reflective. The dark blue, that's a material that has a very high mineral content and is not as reflective as the other rocks. And the light blue, those are recent meteor craters, and they cause the rocks to change when they hit. So you can see that Mercury has pretty impressive and interesting geology. It is not just a plain dead rock. Mercury does have a core, just like Earth does, and it has a mantle, an area where the rock is actually fluid and can move. And in the past, it did have active volcanoes, although we haven't seen any active volcanoes since we've been looking at it.
Ooh, so there was no atmosphere. Is that why there are so many crater marks?
Yes, Mercury really does not have much atmosphere to speak of at all. And because of this, and because it rotates so slowly, the side facing the sun is incredibly hot, and the side that is not facing the sun is incredibly cold.
Well, 59 Earth days for one day on Mercury?
Sunrise to sunset on Mercury would take 59 Earth days. And during that day, the temperature would be more than 420 degrees Celsius. That is incredibly hot. And at night, it would be colder than negative 170 degrees Celsius.
Whoa.
So Mercury is not a friendly planet for human beings to visit.
I wonder if you were like on the boundary, the night and day boundary, if there's like some sweet spot where the temperature works out to be just right. And if you keep running like, it's the cold's behind me, but the heat's ahead of me, but I've got it.
When you're on a planet that doesn't have an atmosphere, there's no such thing as a sweet spot. But if Mercury did have an atmosphere, maybe you could run at that boundary between day and night and try and stay somewhat comfortable. Now let's move on to our second planet in the solar system, Venus. You thought Mercury was hot, but that was just because you hadn't been to Venus yet. Venus is even hotter.
Wait. But Venus is further from the sun.
It is further from the sun, but it has a very thick atmosphere that is mostly carbon dioxide. That atmosphere traps heat like a very effective thermal blanket. And Venus is hardly spinning. Its rotation is very slow, and its rotation is also backwards. It spins the opposite direction from Earth. We think probably Venus was hit by something really large early on when it was formed in our solar system, and that caused it to almost stop and then maybe start spinning backwards.
And the other planets all go the same direction as Earth?
Most of them do, yes. So that's a bit of a mystery about Venus. The day on Venus is longer than a year. That's how slow it is rotating. It takes 243 Earth days to go from sunrise to sunset.
So a day, we're talking about one full rotation of the planet around itself, and a year, we're talking about the planet going around the sun and coming back.
Exactly.
And you're saying the rotation one time around is slower than
going
the whole
all
trip
the way around the
sun.
sun. Yes.
Oh, that's weird to even think about.
It is bizarre.
So, today's my 10th birthday, but I've only been alive for 9 days.
That's exactly what it would be like if you were living on Venus. But living on the surface of Venus would be very difficult. The pressure of the atmosphere is so thick that it would be like being underneath a mile of water. And it is so hot. It's even hotter than the side facing the sun on Mercury, more than 462 degrees Celsius. That's hot enough to melt certain types of metal. If you had a bar of lead, or if your spaceship or special satellite was made out of something where lead was used, the lead would just melt and drip off your spaceship. It's so hot.
This isn't a real picture, is it?
This is an artist picture that was drawn, imagining what the surface of Venus might look like, because there are active volcanoes and there are plate tectonics, which we'll talk about more on Wednesday. But there's no ocean. So this is just an artist imagining what the surface of Venus might look like. Now, Venus is slightly smaller than Earth, but it's close to being the same size. So sometimes we call it a sister planet. It's like a really scary sister planet.
This evil demon sister planet.
Then we come to Earth. And if you were to approach Earth from this North Pole direction, this is what you might see. A beautiful planet with green where we have plants growing, blue where we have ocean, and then, of course, a lot of white.
So the white is from clouds and maybe snow?
Clouds.
Do the other planets have clouds?
Other planets do have clouds. Venus has lots of clouds, but the clouds on Venus are actually made out of sulfuric acid droplets, and it rains sulfuric acid. The clouds on Earth are made out of water vapor. Sulfuric
acid would be bad, right?
Yes, very bad.
Man,
Venus
demon planet.
Venus is a very rough place to try to visit. Now, Earth has a moon, and it's the first planet in our solar system tour that we've seen that has a moon. Venus and Mercury do not have moons. And there's a quick video that I want to play that shows us the size of the moon compared to Earth. And it also shows us a different view than what we normally see, because our moon is locked to Earth, where we always see the same size, the same side. And this is looking at the back side of the moon. And this is a real photograph. This was taken by a spacecraft, and it happened to be in between the Earth, the moon, and the sun. And so we're seeing the Earth as it passes in front of this spacecraft.
Whoa.
Isn't that an awesome view?
So that's the side of the moon we never get to see.
That's right. That's sometimes called the dark side of the moon. It is the side of the moon that we don't see because we always see the same face.
You said the word for that, it was tidally locked?
Tidally locked. And we'll talk about this more in a future class. Huh. Now, one more picture of the Earth just to compare it to our other two planets. Our atmosphere, of course, is a wonderful blend of nitrogen and oxygen. Our day and year are the ones that we are used to. And the surface temperature is really cool compared to Mercury and Venus, only about 15 degrees Celsius, and we have one moon. Beautiful Earth. Isn't that a beautiful planet?
It is, and makes the other planets seem boring just with how colorful and...
It's beautifully colored.
Yeah.
Now on to Mars. Mars is our other neighbor, and it's a colder neighbor than Venus. It does have some water. You can see that little polar cap up top with some snow. One of the cool things about Mars is just how active it was when it had active volcanoes. So there's a canyon on Mars called Valles Marineris. It is almost as large as the United States from end to end. This makes the Grand Canyon look like a little ditch. This is huge. It's more than 7 kilometers deep. That's more than 4 miles deep and hundreds of miles across. It is an enormous canyon. And the volcano, the largest volcano on Mars, is the largest volcano in the solar system. It's called Olympus Mons. It's more than 3 times taller than Mount Everest. And the base of that one mountain would be as big as the state of New Mexico.
Oh my goodness.
Yes.
Okay,
Enormous.
That is huge.
Now, the atmosphere on Mars is mostly carbon dioxide, but it's very thin. We could not breathe it. Even if the atmosphere were mostly nitrogen and oxygen, it would not be breathable to us because it is so thin. So Mars, even though it can get as warm as 20 degrees Celsius, which is like a nice spring day to us, it would not feel that warm. If you were standing on the equator of Mars in the middle of the day, your feet might feel like they were 20 degrees Celsius or about 75 degrees Fahrenheit, but your head would feel like it was wintertime. Your head would feel like you were freezing.
Wow. Now, just so a day is 24 hours and 37 minutes. That's almost the same as an
Really
Earth day.
close, yes.
The rate of rotation
is really similar to Earth, but it does take almost twice as long to go around the sun if you're on Mars. So the year is about twice as long, but the day is really similar.
But it seems like of all the planets in the solar system, this one is the most compatible, or the closest to being compatible.
Definitely. And that's one of the reasons why we are trying to explore Mars more.
I've got a question for you. These are all crazy round. Why do they look round as a ball? They're almost perfect spheres.
It's because they're so big. So gravity is a pretty strong force. And one way to think of gravity is to think of it as things being pulled together and sticking together. And if something is big enough, gravity is going to pull inward and it's going to make that object round. So we have our sun, which is very large and round. If our sun was this size, then I want you to take just a minute and just take a guess for how big would Earth be? Would Earth be the size of a pea? Would it be the size of our thumb? Would it be the size of a tennis ball? How big would Earth be?
Ooh.
And the answer is this big. So here are our first 4 planets: Mercury, Venus, Earth, Mars. Earth is the biggest of those 4, but compared to the sun, it's pretty small. But each of these planets and Earth's moon, they are big enough that gravity shapes them to be round. But now we're going to meet the 2 moons of Mars. They are not big enough to be round. They look kind of like lumpy potatoes. There are the moons of Mars, Phobos and Deimos, and they are not big enough to be round. They're still pretty big. You could land a spaceship on them, but they're not large enough to be nice and round. And Phobos is getting closer and closer to Mars every year. And in a couple 100 million years, it's actually going to get pulled apart by Mars gravity and turn into a ring, just like the ring of Saturn. It'll be a bunch of little small broken rock pieces around Mars.
Oh, wow.
Isn't that kind of cool?
Yeah. Okay. And the reason you said that they're not spherical is that they're not big enough. They don't have enough gravity to make force that shape.
Yep.
Weird.
We are going to go to this website real fast just to show you some really incredible little graphics about Mars. And if you want to learn more about Mars, this is one of the best sites, mars.nasa.gov, all about Mars. So the first kind of fun fact to think of is that the atmosphere on Mars is so different and so thin, mostly nitrogen on Earth to mostly carbon dioxide and super thin. But because Mars is so much smaller than Earth, if you were walking and running on Earth and then all of a sudden you got teleported to Mars, you would feel like you were a superhero leaping across the landscape. The gravity is a lot less strong on Mars.
That looks so much fun.
It would be fun to run around on Mars. The structure is somewhat similar. Mars did have active volcanoes and it did have a mantle and a core just like Earth did. And we'll talk more about Earth's structure on Wednesday, but it does not have active volcanoes right now. And then this last little graphic I wanted to share is just that fun graphic to show how much larger Earth is than Mars. You would need 6 Mars planets put together to equal Earth. Earth is quite a bit bigger. Let's hold up our sun one more time and look at our inner solar system planets. So these are all rocky planets. They all have a crust, a solid rocky material that you could land a spaceship on and then you could walk around on top of. And at one point, all of them had active volcanoes where lava would come out from inside the heated core of the planet. You would have heat driving melting of the rock, and then lava would come out and form things like volcanoes. But when we go to our next planet, whoa, it is very different. The first thing you'll notice is that it is huge compared to Earth. And the second thing that is strange is that it is made mostly of gas. Malcolm is exactly right. Rocky planets and the gas giants. We're moving on to the gas giants now. And the first gas giant we're going to talk about is Jupiter. Jupiter is enormous compared to Earth. And it's so big that it has a really strong magnetic field and it has really strong gravity too. And because of that strong gravity and that strong magnetic field, the pole of Jupiter actually has some really amazing auroras and a beautiful blue color. Isn't that amazing?
That is amazing. So just on this previous one, I actually know something about this. There's a evil red eye right there.
That is not an eye, Math Dad. That is basically a huge, enormous hurricane. It's called the red spot, and it is very famous. This is a huge storm system, and hurricane is really too small a word for what this is because it is way bigger than our entire planet. But this is a swirling storm of gas that has been going for as long as we know of.
Wow.
Our earliest telescope pictures of Jupiter have this same storm.
A storm as big as our planet. Crazy.
Yeah. And the poles of Jupiter have incredible color as well, and storms. Each of these spots you can see, these are all enormous swirling storms of gas rotating on the planet. Now, Jupiter has a lot of moons. And when I say a lot, I don't mean just 2 or 3 or 4. Jupiter has 79 moons.
You're serious?
Yes. And
Whoa.
This one, Ganymede, is the largest moon in our galaxy. Now, what's the difference between a moon and a planet?
I know the answer to this.
What is it?
Okay, so planets, their primary orbit is around the sun, and moons have a primary orbit that's around a planet.
That's right. So our moon, it is going around the sun, but first and foremost, it's going around Earth. It's circling Earth. And these 4 moons, they are orbiting Jupiter. And Europa could be a good candidate for life to exist because it has an ocean of water, which is underneath a big, thick layer of ice. One more thing I want to point out about Jupiter before we go to our next planet. The day on Jupiter is super short.
9.6 Earth hours.
Yes, that is the shortest day of any planet in our solar system. It takes it a long time to go around the sun, more than 4,000 Earth days to travel around the sun. But its actual day, sunrise to sunset, is very short.
So it's the biggest planet, but it also is rotating the fastest.
The fastest.
So on the surface, you'd just be...
Well, is there a surface?
Wait, there's not a surface?
There is not a surface to Jupiter. Jupiter is a giant cloud of gas. It is a gas giant. And just like when you're on Earth, if you're up in the mesosphere, the air is super thin. And then as you get down to the surface of our planet, the air gets thicker. On Jupiter, the air gets thicker and thicker the deeper you go. And eventually, in the center of Jupiter, they think that there is a solid core because the pressure is so extreme. But Jupiter is mostly made out of hydrogen and helium. It takes a lot of pressure for those gases to become solid. And the solid core in Jupiter, they think, is made out of heavier elements, but we don't know for certain yet because we haven't ever been able to get close enough to take good readings.
So it doesn't even make sense to ask a question of, does it have an atmosphere?
The
Because
whole thing is
a gas.
Yeah.
Oh man, that's a really interesting observation.
So mostly hydrogen and helium, and it's a gas giant. So if you tried to land on the surface, you would just keep going down deeper and deeper and deeper until the pressures got so extreme that you'd get squished. Because Jupiter is very big and the pressure on the inside would be extreme.
Wow.
Next gas giant we have is probably my favorite planet just because the rings around this planet and the number of moons it has are incredible. Saturn is also a gas giant, and it has beautiful, beautiful rings that are mostly made out of dust, ice, and little pieces of rock. And the gravity of the planet is slowly pulling these toward the inside. It has even more moons than Jupiter.
82 moons.
82 moons. And one of them, Titan, is really big and has enough water on it that there could be life living underwater on Titan.
Okay, that is crazy.
Isn't this picture amazing? On this picture, you can see, and I'm sorry, I went a little too fast on this other one. Real quick, the day on Saturn is 10.7 hours. So it's rotating pretty fast, just like Jupiter. And it is not quite as big as Jupiter. If we hold up Jupiter next to a little model of Saturn, you can see that it is a bit smaller, but it's still a really good sized planet. There's a reason why we call them gas giants.
Okay, so what are the rings made of?
Ice, dust, and bits of rock. And look at that shadow that is cast by these rings up onto the planet. Isn't that beautiful? And you can actually see some of the moons in this photo. This little white dot here, that's one of Saturn's moons. This is one of Saturn's moons. And I believe here, and
no, those are just dirty spots on our iPad. But you can see a shadow of a moon here.
You can.
And I don't know if that's one of these other ones that we can see here or if it's somewhere else, but yeah. Okay, that is absolutely gorgeous to look at. If you were on the, well, somehow, if you were on the surface, if you were
floating in the atmosphere of Saturn,
you would be able to see all these rings?
You would see these rings. And from Saturn, the rings would look more white. And like we mentioned earlier, the rings eventually the gravity of Saturn is going to pull them in and they're going to become part of the planet. But the moons will continue orbiting, and several of the moons of Saturn are really big.
And I will say, as you get so far away from our sun, you get a lot less light. So things would never get very bright on these planets. So I imagine it could be difficult to see the rings just because it's so dark.
It would be really neat to be able to visit Saturn. The next planet is not a gas giant. It's what we call an icy giant. And this is a little bit of a misnomer. A misnomer is a name that kind of confuses because it maybe doesn't have quite the right meaning.
It's a misnomer, a misnaming.
Misnaming, yes.
Yeah, okay.
So Uranus, sometimes people pronounce this Uranus, but the classic definition, the classic pronunciation that astronomers use is Uranus. Uranus actually rotates on its side. It rotates sideways. So like Venus, we think probably it got hit by something really big early on when it was forming and it got knocked sideways. It does have 2 rings, but they're very faint and hard to see. And it is mostly liquid. But it's a crazy type of liquid. It's made mostly of water, ammonia, and methane. It has a very thick atmosphere, but then if you get down underneath that atmosphere, then you get to this superheated liquid ionized ocean of material. And then at the center of that, you have a core. So we call these ice giants because ices in astronomy, ices usually refer to water, ammonia, and methane. And if you have just water, ammonia, and methane on their own out in space, they are in the form of ice. And when these planets were formed, it was these icy materials coming together that formed most of them. But once they got that big, instead of being frozen ice water, the water turned into
superheated material. That's why they're called ice giants.
Yeah, I told you it was a misnomer. It's a little weird.
I like it.
Uranus is also rotating pretty quickly.
Can I ask just
Yes.
a second? So if we're dangling out in the middle of space, Saturn's a good one because we can hold it up. So it's just dangling in space. How do we know what up and down is? How do we know it's on its side? Like, what does that even mean? Because I can turn it any which direction, and how would they know the difference if you were there on Saturn?
That's a good question, and it has to do with how planets form. Planets form from a big disk of rotating gas and rocks and other material. And all of the planets circle the sun on the same plane. So here's our sun, and then Earth is going around on this plane, and behind it, Mars is going around on the same plane. And so they're all circling on the same level, and then they're all rotating the same direction except for Venus, which rotates backwards, and then except for Uranus, which is rotating on its side as it goes around.
Because I thought, well, why don't you just turn your head sideways? And then it's all the other planets that are wrong. But you're relative to this plane of rotation around the sun. Okay, that makes sense.
Yep.
Good answer. You passed. I was just testing your science.
I'm glad I passed. The day on Uranus is 17 hours and 14 minutes, and the year is 84 Earth years. And the reason it's blue is because of the ammonia in its atmosphere. Its atmosphere is mostly hydrogen and helium, just like Saturn and Jupiter, but that ammonia gives it that blue color. And it is definitely cold out there on this planet if you're up in the atmosphere, but if you get down deep enough where the pressures are high enough, the actual water ocean of Uranus is kind of crazy. Super high pressures, a lot of ionized particles, not friendly to life as we know it. And then there's a picture of Uranus taken by Voyager, one of the first spacecrafts that we sent out. And the resolution was low enough you can't even see the rings because they're very thin compared to Saturn.
That's cool. I didn't even know it had rings. So.
And then last but not least, we have Neptune. Neptune is also an ice giant, which means it has this ocean of quote unquote icy materials, water, ammonia, and methane. And a day is 16 hours, so it's rotating pretty fast. And again, the blue color is from the methane. It's even bluer than Uranus.
That's gorgeous.
Isn't that pretty?
Huh.
Now, we used to call Pluto a planet as well, which is beyond Neptune. We don't tend to call Pluto a planet anymore because Pluto is actually part of a belt called the Kuiper Belt. And the Kuiper Belt out beyond the solar system, if you were to call Pluto one of the sun's planets, there are about 200 other objects that should also be called planets because they're very similar to Pluto.
That's good. Yeah, because when I was growing up, they always taught us there were 9 planets, and now we're saying there are 8. And that's because we've reclassified Pluto. We said, okay, we might call it a dwarf planet or give it some other designation, but it doesn't really match the other 8.
It doesn't.
It also isn't quite perfectly in that planetary plane. And kind of a fun fact, when I was a kid, Pluto was closer to the sun than Neptune. It has an irregular
It has a
orbit.
crazy orbit. It does.
It's no longer closer than Neptune.
Now, in our notes, we have a little section where you can come up with a way to remember the order of the planets. So we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And if you come up with another sentence that fits those words, you can draw a picture of your mnemonic device, and it will help you remember the order of the planets. Do you want to see mine?
Yes. So my very excited monster just snaps up nachos.
That's the one I came up with, and I drew a picture of a monster eating nachos just for you.
Aw.
And you can draw your own and then share it with us. If you come up with a mnemonic, we would love to see it. You can email it to us or tag us on social media.
Mnemonics are pretty cool
They are.
Being little tricks to remember things that you don't use that often. But.
And now let's get to the big question about how planets form. Because it turns out that they form from stellar nurseries or nebulas. A nebula is a giant cloud of gas and dust and other materials. And nebulas are formed just in the life cycle of stars. Stars will form and then they will get big and they will either explode into supernovas or they will collapse. And everything in the universe is moving around. And as things collide together, you'll get these collections of dust like this galaxy. And this galaxy is actually forming new stars. Here's another picture.
Violet's in the chat saying, my very educated mother just served us nachos.
That's a good one too. I like that mnemonic. Here's a picture of the Rosette Nebula, a picture that was taken by one of the NASA spacecraft. And you can see that bright glowing spots of light. Those are new stars forming. And the way that a star forms is really just, you can think of these bits of dust as like little balls of clay. And if you have a bunch of little balls of clay floating around in space, when some of them start to stick together, the amount of gravity they have gets bigger because the bigger an object is, the more gravity it has. And then they'll get more and more pieces stuck to them. And eventually they can get big enough that they start to become a star. And around that star, you will get planets. Now let's go to the notes real fast and take a look on page 60. I want to point out something. If you have the first version of the notes, instead of a stellar nursery here, it says planetary nebula. And if your copy of the notes says planetary nebula, you can take a little pen and cross it off and write stellar nursery above it. That's actually another misnomer. Planetary nebulas were named planetary nebulas because when astronomers first saw them, they said, oh, they look round like planets. But they're actually what forms after a star is at the end of its life cycle. And when a star is dying, that's when you get a planetary nebula. So a stellar nursery or nebula is a cloud of gas.
So planetary nebula should be called stellar nursing homes.
Stellar nursery is what they're called.
These ones, because it's a nursery because it's forming.
Yes.
And the other ones at the end of the life cycle would be a nursing home, right?
I guess so.
Oh, it's brilliant. Trademark.
It's a good joke, Math Dad. It's a good dad joke. A stellar nursery or a nebula is a cloud of gas that becomes thick and dense enough where things will condense into planets. And closer to the star, you have a lot more radiation coming out from the sun and a lot more powerful gravity from the sun as well. And the way things stick together, you tend to get rocky planets closer to the sun. And then farther out, the gravity is not as strong from the sun, and you don't have as strong of solar radiation coming off, and gases can collect together, and that's where you get the gas giants. So it's not just in our solar system that we see rocky planets on the inside and gas giants on the outside. We see this in other solar systems too.
Okay, and when we use the word solar system, so that's just our suns, so things that are orbiting the sun.
Yes.
And then in our solar system is one thing inside of a galaxy, which has lots of other star systems. And so our galaxy is this whole chain of star systems that are rotating, but there are other galaxies as well.
There are, and we can see other galaxies, and the way we know how planets form and learn about how our planet's formed is by looking at other planets that are being formed right now in nebulas in other galaxies.
How many galaxies are there? Like 100? 200?
Like trillions.
Trillions.
Wow. Lots and lots. Now, we are getting a little shy on time, and I want to make sure that we have time for our questions. So, Math Dad, are you ready for a mystery?
Yes.
Okay. Your mystery, before I give you the full clue, I'm going to give you part of it and see how good you are. What city is called the mother of the world sometimes?
What city is called the mother of the world?
So this is our where in the world mystery. The answer is going to be a city somewhere on Earth, and this is our clue, our cue to you if you're watching with us live to get your polls ready, because we are going to have poll questions next.
I mean, I guess it's a really old city, but
here's a little bit more of a clue. Sometimes called the mother of the world or al-Dunya. It has the second oldest university of the world and the Giza pyramid.
All right, so it's got to be Egypt, Cairo.
Yep, it is. It is Cairo.
I was going to say that. I thought the first clue, but I didn't dare. It is Cairo.
Good job, Math Dad. Cairo is the largest city in Africa. More than 21 million people live there. And it is a city with incredible history.
Got to get up pretty early in the morning to stump Math Dad.
We'll see. I don't think you're going to stump our unbeatable science kids, because now we've got questions for you guys at itempool.com/sciencemom/live. While Math Dad gets that ready, I'm going to go and grab our science puppy real quick.
Excellent. All right. For our first question, which planet has the hottest temperatures? So you got Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. And I always try to say them in order just so I remember it, because that helps me to remember which one was closest to the sun, which one was farthest, and their relative distances. Okay, watching the votes come in here. Kind of a cool fact. It turns out each planet is almost twice as far from the sun as the planet that came ahead of it. Almost twice as far, I mean, like 80% further on average. It's not an exact number, but the gaps seem to get bigger each time. All right, I'm going to finish and reveal.
Venus is correct. Nicely done. Venus is the hottest planet by quite a bit.
And Mercury, which is weird, because you'd think Mercury would be the hotter planet.
Yeah, Mercury is second hottest.
Question 2. Neptune and Uranus are
they
ice giants, gas giants, or rocky planets?
Jackie would like to know, or ask, is it true that the moon used to be closer to Earth? And it is true. The moon is actually getting a little bit further from the Earth every year.
No, come back, moon.
And eventually, millions and millions and millions of years from now, we could lose the moon. The moon could travel off. But I think the sun's going to expand and take over the solar system before that happens, I believe.
Oh.
I don't know the exact timeline. But most planets do eventually lose their moons by having them travel out too far, or their moons will crash too close, like Phobos and Mars.
That's super interesting.
It's something that takes hundreds of millions of years.
They said ice giants. That is correct.
Nicely done. Nicely done.
All right, question number 3. Which planet rotates on its side?
Another question that our moderators sent into us. It's a really good one. Kara would like to know, if there's no water on Mars, how is there snow? There used to be water on Mars. In fact, there used to be a lot of water. We see evidence of rivers and deltas and floodplains. There used to be a lot of water on Mars, but the magnetic field that protects the atmosphere on Mars is not as strong now as it used to be, and Mars has lost a lot of its atmosphere. And when the atmosphere got that thin, now there can't be liquid water on Mars because it will just go up into the atmosphere and then be blown away, basically. So ice is the only water left on Mars. Also, Mars is cold.
That is true. All right. G. What's G? Uranus
is the only planet that rotates on its side. Very nicely done. That is correct. They're on top of it today, Math Dad.
Not bad, not bad. All right, but will they get this one? Select all planets that are smaller than Earth.
Mimi has a great question. How does the hurricane on Jupiter get started and keep going? It has to do with just how fast Jupiter is rotating. And then as Jupiter is rotating, and I think with Saturn too, you have different densities of gases in different areas of the planet. And then that difference in just how fluid the gas is, how well it moves, causes a lot of interesting patterns.
This could be the one, Science Mom.
I don't think so, Math Dad.
Oh.
Because there are exactly 3 planets that are smaller than Earth, and we have 3 bars that are going out and getting you.
Mercury, Venus, and Mars are indeed smaller than Earth.
Yay! Go unbeatable science, kids.
Yeah. Once you get to Jupiter and beyond, those are all bigger than Earth. All right. And our last question. Which of the following facts about Venus is false? So select false facts. A year on Venus is longer than a day. Venus spins from east to west, so the opposite direction of Earth. Venus is slightly larger than Earth. And the clouds on Venus are made of sulfuric acid droplets.
Whoa. And while we're having answers there come in, I want to answer a question that came from Julia real quick. They ask, how many planets have humans landed on? And this is a good question. If you mean actual humans have like stepped out of a spaceship and been on a planet, the answer is 0. We've only been to the moon. But if you count us putting something like Perseverance rover on a planet as humans landing on a planet, because then we're getting data from that planet, the answer is Venus and Mars. And then we did intentionally, on purpose, we crashed one of our probes into Jupiter. So does that count?
Saturn? The Cassini?
Yeah.
Yeah.
Jupiter as well. So for sure, we've got 2. And then with the gas giants, it kind of depends. Like if we fly a probe into there and know that it's going to get crushed by the pressure, does that count as landing? If there's no surface?
Hard
I don't know.
Say, yeah. All right. And they said that Venus is slightly larger than Earth is false.
And that is the one false statement. All of the other statements are true.
But look how many of the other answers that they selected. If you add all those up, it's worse.
I don't think
it's
that
more
counts.
votes than what?
I don't think that counts, Math Dad.
Oh man.
All right, those are our 5 questions for today. Nicely done, you guys. Good job. And we do not have, I did not see any birthdays today, but Math Dad, I think you're just trying to distract them from seeing the victory dance.
Don't they want to hear a birthday song or something? No.
Try a worm.
And I wanted to see the chicken worm again because that's, I think, my personal favorite.
It's a beauty.
It makes me laugh each time I see it. All right, we're going to answer just a couple more questions really quick. Clara says, some people say it rains diamonds on some planets. Does it? This is a great question, and it all depends on how you define rain. There are certain planets that are large enough where there could be enough pressure that any carbon could actually be condensed into a diamond form. But the pressure is going to be so high at that levels where you would get diamonds formed that even if they were kind of traveling through, it wouldn't be, there's no surface on these planets, on Jupiter and Saturn. And so it wouldn't be rain like how we know rain. But yes, diamonds could form because of the intense pressure on those planets.
Wow.
And then 2 more.
It's amazing to think about.
Yeah. 2 more questions real quick.
Do the planets have sound?
It all depends on which planet. So if there is no atmosphere, there's not going to be any sound. So on Mercury just has an exosphere. There are just a few molecules. It's pretty much like outer space. There would be no sound.
Well,
on Mercury.
Sound waves could travel through the planet.
Yes,
Yeah,
but if you were
through the solids, but yeah, you wouldn't be able to talk to somebody.
no, if you're standing on the surface, you wouldn't be able to talk to anybody. But Jupiter and Saturn, the gas giants, there would be sound on those planets, but the planets have such incredible winds. I mean, it would be like standing in the middle of a hurricane, pretty much anywhere you were in the atmosphere.
So you couldn't talk then either.
Yeah, it would be really windy. And then great comment from Coaster Cody. So Saturn will lose its rings and Mars will gain rings? Eventually, probably yes. But when I
Wow.
say eventually, I mean 100 million years from now, a long, long time from now.
Got to be patient if you're going to see that.
Yes, that would take a lot. And then the last question from Aerosky is, can Saturn's rings collect enough rock and ice that it would be thick enough to actually land on? Ooh, that is a good question. The Saturn's rings, some of them are thicker than others. I do not believe that any of them are thick enough that we could land on them. But Math Dad, right, as a final thing before we go, let's take a look at the NASA view of Saturn, if you could pull that up real quick. So I will say real fast, and let me share this website with a little banner so you guys can see it. Solarsystem.nasa.gov has incredible pages for each of the planets in our solar system. And if you want to take a look there, there are incredible facts about each planet. So if we look at the rings of Saturn, you can see that they look almost transparent.
Yeah.
There is enough dust and material there to capture the light and to reflect the light, but it wouldn't be thick enough to land on.
Whoa. Okay. This is fun. I get to drive it all. I'm spinning it.
You do, and you can zoom in and zoom out, and that is like a real-time photograph that has been put together from a spacecraft orbiting the planet.
Well, it's
a simulation.
Simulation, yeah.
Yeah, but it's
based
on
off
real
of
data.
the way that it would. Yeah, so if you could fly around the planet, this is what you would be seeing. Although it feels like I'm moving the planet, which is even more powerful.
All right, let's come back to our main view. We hope you guys enjoyed learning more about planets and about how they form. And we will see you on Wednesday with a lesson all about the structure of our planet Earth and plate tectonics.
So, Kaladin wants to say goodbye.
Yep.
Work hard, grow smart, and we'll see you next.